Okay, so we're on to question 59, and it's just a simple solving a log problem. So it tells us that log base 3 of t equals 1 half. So the first thing we could do is, I'm going to say base this. I don't think that's the official terminology, but raise 3 to this log base 3 of t power, and of course we have to do it to both sides. So that means that this cancels, so t equals square root of 3. So the first part is really simple, just simple log. And now it's asking to find the solutions for all log base 3 of tan of x equals 1 half. Now you can see that everything is the same except t is equal to tan of x. So that means that tan of x has to equal square root of 3. And if you do or inverse tan of square root of 3, you should get pi over, that's 3 over 1 half. So that's when it's 60. So that's 3. I'm pretty sure that's 60 degrees because that's square root of 3 over 2 divided by 1 half. Yep. Sounds right. So the answer should be pi over 3. However, it says tan x equals square root of 3. So when we found the inverse, remember the inverse has a domain. But since we are given that it could be any x angle, it could be pi over 3, but it could also be, one sec, let me x. It can be pi over 3, but it can also be pi over 3 plus any 2 pi a, meaning it could go in a cycle, right? Because that same angle could be reciprocated just by adding 2 pi because it goes around a circle. So that's why I would like to mention that this 2 pi a portion of the equation, but of course a has to be an integer because it has to do a full loop, right? A full 2 pi loop. In math, I don't know if anyone's interested, you would format it as a is an element of the integers. But if anybody was, I don't think anybody here is interested in this, but that's how you would write this top part. Pretty simple problem. We can move on to the next one. Okay, so on to question 54. So there's an elaborate looking shape over here, and there's a lot of steps that are kind of unnecessary to tell how this works. Um, for this question, I'm actually gonna mix it up. Like I'm not gonna start a question. I'm not gonna start part A. Um, here, uh, there's two functions we need to know about. We need to know about p sub n, oh, p sub n, and u sub n. And then we are given a sum right here, just and we don't know what this is yet. But you can look and you can spend like 5 seconds and realize this is the sum for p sub 100. And you can look at it because the shaded triangle is 1/4, and then it becomes 1, 2, 3 out of 4, 8, 12, 16 triangles. So then it's 3 out of 16, and you see that just by looking at it, it equals p sub 100. So we're now gonna do question B and C. Uh, Knowing that, uh, and we'll do A after B and C. Actually, we'll do E, B, and C at the same time, or E first, then A, then B and C, and then we'll go on to D. So it's gonna be interesting. Never had this problem is ordered weirdly, but for this is obviously P. So, and it's obviously a sum with a it's a geometric sequence. So we're gonna do the sigma as n equals 0, and this is goes to 100. But here we're gonna go whatever value we want w. 1 over 4 times 3 out of 4. Yeah, because, yeah, to the W. And I think that's good. I think that's good because 3 out of 4 and 1 over 4 times 3 over 4 is 3 over 16, then 9 over 64, and it goes on, it goes on. So I think this is a good geometric sequence to provide for P sub W. I can't. Can you see that? Yep, P sub W. Now, oh, I didn't do equal. Now, for U, it should just be the complement. What does the complement? It means that it should fill the fractions that was left behind by the other. So what does that mean? So if I write it out, it would still be the same sigma from n equals 0 to W. And then since it's 1 over 4, to make it 1, it would be 3 over 4. And then instead of 3 over 4, I was thinking about this for way too long. I first thought it was 1 over 4. It's actually 3 over 4. The same thing as, oh, no, not W. As P. And the reason why is because it's technically P and W are recursively decreasing together. So it should be the same. It should be the same rate. I don't know why I didn't think. And you can write out the sequence too. You can notice that this is you start with 3 over 4, and then you count, and then you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 over 16. 9 over 16, and then this is another 9 over 16. So 9 over 16, and whatever that is, just simplifies to 9 over 16, which is when it multiplies by 3 over 4. So it's the same. It's the same pattern. So for U sub, oh, and we could just get B, C, and E just done really quickly. B would be U to the N would be equal to U to the N minus 1 times 3 over 4 when U to the 0 equals 3 over 4, and P to the N would equal P to the N minus 1 times 3 over 4 when P sub 0 equals 1 over 4. So now we're going to go to, so that was B and C actually, real quick. That was really easy. We just used the sigma notation. We just convert to sequence notation. Now we're going to do D. Should we do E? No, we're going to go to E, which, again, is very simple. We already wrote down most of the work. So it would be the sequence of W to W, but in this case it's 100, P to the 100, right, which I wrote over here. N equals 0, 1 over 4 times 3 over 4 to the 100. So that's, I think, really simple. And for D, we could solve this. So D equal D. I don't know why I erased that much. Is 1 over 4 times 1 minus 3 over 4 to the 100 over 1/4. These cancel. So this is 1 minus 3 over 4 to the 100th. And I need to do this in Desmos. And it's a very small number. This is a really small number. Even Desmos won't round to it. Um, yeah, it's a big number. It says 1, but take it or leave it. Just can't. You can't round it that. You can't go that high. And then for A, this is now we're going to go back to what the problems we're supposed to solve. Um, P1 uh, should just be 3 over 16. And I'm just copying. And by the way, I'm just using these numbers right here. I'm not copying from anything else. P1 should be 3 over 16. P2 should be 9 over 64. B3 should be, and this times 3 over 4. So this would be 27 over 4, which is 240, 256. For P, this is the P series. Well, that's not P series. And for U, it should just be the same series, but starts at 3 over 4. So U1 should just be 9 over 16, then 27 over 256. And then the third series should be 3, 60, 60, 60, 51 over 3, 600, 750, 780. I did that really fast. I need to make sure I'm right. I don't think I'm right. 3, 18, 3, 600, 750, 768. Yeah, that looks more right. And that's for the U series. So hopefully this proves that you can go backwards and do the problems not in order and still get the answer. So yeah. Okay, so other question 61. A function f is defined by f of x equals inverse sine of x. Draws a graph and find a period. Like I said multiple times, just graph on Desmos. Or if you don't want to graph on Desmos, you can also just plug in random values of x and draw what it looks like. It looks like this. I don't remember if it intersects um the what am I saying? If it intersects the x intercept, and it does, but so I'm gonna actually erase this. It looks like this, and then it looks like this zigzag, and it intersects at this point there on the rise up. Okay, so it should be like this. There we go, something like this, and the period doesn't ever change. Like there's no amplitude of the x, there's no coefficient of x, so the period will always be 2 pi. And yeah, pretty easy homework for this week, except for the fractal. Um, but yeah, I just recommend using Desmos for this one.